Okay, this is part 5, our last part for our lesson 8.8 AP Cal curriculum, volumes, cross sections, triangles, and semicircles. In this video, we're going to do an example problem with more complicated functions than what we did in our first 2 examples. So we'll look over here and let's look at, there's our rules again for everything we do when we're doing the cross sections. This one's going to be a little more complicated because we're going to look at functions f of x equals cosine x and sine x, determine the volume of the solid whose base is defined by the region in the first quadrant, bounded by the curves f of x and g of x, and the y-axis, and the cross sections are semicircular and perpendicular to the y-axis this time. So we throw 2 curves in here and we make it perpendicular to the y-axis. Make it a little more complicated than what we've been working with. Let's sketch this real quick. And if we look at this, the x-axis, we haven't done that yet. We're going to, but we haven't done it yet. All right, we look at the curve y equals cosine x. Whoa. And we look at the curve y equals sine x. Well, that's not carried away because it didn't really matter. And so now what we're looking for is this region in here is going to be the base of our solid. And we're going to have a rectangle. But now, since we're doing this with the y-axis, we're going to take our functions and we're going to solve for x. So when I solve y equals cosine x for x, I take the cosine inverse of both sides and get x equals cosine inverse y, or arc cosine. Remember, we can write it like that. And when I take sine x, I get y equals sine x. I take the sine inverse of both sides, and I get x equals sine inverse x, or sine inverse y, sorry. So when we do that, it allows us to flip our axes. I want to redraw this with the y-axis down here this time. Our x is our independent variable now. And what we're going to see when we flip this is, recall that sine inverse comes up and goes like this. Well, let's just lag on the computer screen a little bit. And the cosine inverse starts at, let's see, cosine inverse, when I flip that, it's going to look like this. And so now we're looking for this region in here. We need to understand this intersection occurs when x is equal to pi over 4. So that's when the cosine and the sine are both the square root of 2 over 2. So now the y value here at the end, well, missed that. Y value at the intersection is going to be the square root of 2 over 2. And that's going to be important because we're going to need 2 rectangles and 2 integrals this time. We're going to need rectangles in this section to the left and another one in this section to the right. So the first one, we're going to look at this, the rectangles here, because that's going to be defined by that sine inverse curve. So we're going to look at one cross section. These are semicircles, right? For that first part, we have dy now, and then the length here is going to be sine inverse x, or arc sine x. So the radius of that semicircle is 1/2 arc sine, or sine inverse x, y, sorry. So this part's only going to apply for this part of the region. So this part, we're going to get the volume of the solid by integrating from 0 to the square root of 2 over 2. And now remember, semicircles, area of a semicircle is equal to pi r squared over 2, or pi over 2 times r squared. So the volume of this one, that's not the volume, is it? 1/2. This is going to be the radius. That's the radius. That's not volume. That's what it was. So the volume of one of these is going to be, the volume of one of these is going to be 1/2 times sine inverse. Let's back this up a little bit. That's the radius. So this is going to be the volume of one of these. Is going to be the area times dy. So the area is going to be pi over 2 now times the radius squared, and this is the radius. So 1/2 sine inverse y, a lag here, sorry, squared times dy. So that's the pi r squared over 2, and our r here is 1/2 sine inverse y. That's the volume of just this part here. So now we need to find an expression for the other one. So we're going to pull that out, and we're going to take that rectangle and that semicircle. Still going to be dy. This time, though, the height of the rectangles in this region are going to be the cosine inverse of y. And so a radius in that region is going to be 1/2 times cosine inverse y. So the volume for these, we'll call this V1, call this V2, this is for this one, it's going to be pi over 2 times the radius, which is 1/2 cosine inverse y squared, times dy, and there again I notice I just put a dx up there where I said dy. So this is going to be two integrals. We're going to integrate this v1 from 0 to the square root of 2 over 2 for y. We're going to integrate v2 from square root of 2 over 2 until we get to, this is 1, when y is 1 for the cosine inverse. No, sorry. Yes, that's the y values. So when we set this integral up, we're going to be looking at the integral from 0 to the square root of 2 over 2. We'll put pi over 2 on the outside, and then on the inside is the 1/2 sine inverse y squared dy plus pi over 2 times the integral from the square root of 2 over 2 to 1. And this is going to be 1/2 cosine inverse y squared dy. This would be your integral that you would set up to calculate the volume of the cross section, the volume of the solid generated with cross sections perpendicular to y-axis bound in the first quadrant by the y-axis, cosine x and sine x. And if we're going to integrate that, that again would be something for the calculator to do. So here, I'm just going to type in these integrals, have it calculate that, then multiply everything by pi over 2. So I'm going to do the integral in the calculator. math 9, from 0 to square root of 202, of 0.5 sine inverse, and I'm putting x's in the calculator, remember that. Oops, I've still got to do my parentheses. Squared. Integrate with respect to x. Again, in the calculator, we're changing it to x's plus, now the integral. Math 9 from the square root of 2 over 2 to 1. And this is going to be 0.5 cosine inverse x. And then again, I have to put make sure my parentheses are all in the right place. And then make sure I square the entire 1/2 cosine inverse x times dx. Tell the calculator to integrate. And I multiply that times pi over 2. And this one, pretty interesting, gives me 0.0869 or 0.087. 0.087. Interesting. Okay. And that's units cubed because we're doing volume. And that's how you do more complicated functions.